Hey everyone, this is Unit 3 Notes number 14, Coterminal Reference and Quadrants, okay? Go ahead and write down this FLT and then we'll go ahead and get started, okay? Just a kind reminder to always pause to actually try out the problems and to reflect, okay? All right, here we go. So same as the last few, we're kind of making the connections now before we get into the actual trig, okay? So these are some of the things that you want to master so that we get out of the way, okay? So you're going to be presented an angle like always. Now you're going to have to revisit how to find a coterminal angle, a reference angle, and as always, identify where you are in which quadrant. So there are three things that you want to handle here. Coterminal. We're going to find the coterminal angle. We're going to identify the reference angle. And then we're going to determine where this triangle is, in which quadrant. So three things all connected together. So it shouldn't be new. It's just we're kind of revisiting and spiraling in what we've been learning, okay? All right, so here we go. Write this one in its entirety, and then I'll go over it with you. Okay. Okay, so here, example 1 for the rotation of 751 degrees. Find the coterminal angle from 0 to 360, the quadrant, and the reference angle. Okay, so remember, coterminal angles, just to revisit real quick. Whoa, let's try that again. Coterminal angles are angles that end up in the same terminal side. So if I have an angle here, that's the same thing as going one full circle and then back here. As long as you're ending up in the same spot, it's considered a coterminal angle. You end up in the same place, okay? And the way we do that is it's a mere difference of rotating 360 degrees. So this is kind of like reducing, in a sense, your angles, okay? We're so used to having angles somewhere between 0 and 360 so that when you get anything that's too high or too low, we want to convert it back so that it's somewhere between 0 and 360. So here we go. 751 is definitely way too large. It surpasses 360 here, okay? So what we want to do is we want to make it smaller. So we subtract increments of 360 always for coterminal angles, okay? So if we subtract 360 here, I'm actually going to use my calculator. I get 391 degrees, okay? Is 391 degrees somewhere in between 0 and 360? Okay, it isn't. So what we do is we reduce it again. We subtract another 360 degrees, and that gives me 31 degrees, which is definitely somewhere in between 0 and 360. Okay? It's definitely somewhere in between 0 and 360. So our coterminal angle is 31 degrees. And we know 31 degrees is definitely in quadrant 1. Okay? With a reference angle. So visiting what we did last time, okay? 31 degrees is right here. We're going to go counterclockwise, 31 degrees. We're going to make our triangle. So we have to hug the x-axis. So in quadrant 1, it's easy because the angle presented is the reference angle. So it's actually the same in quadrant 1, but just for quadrant 1. So the reference angle is 31 degrees. And that's it. Let's try some of the more elaborate ones. Here we go. Here's another one here. Okay, 1,215 degrees. Find the coterminal angle. Pause, do as much as you can, and then press play when you're ready, okay? All right, 1215, I shouldn't say 1215. 1,215 degrees is definitely way too large, okay? So when it's too large, we're going to go ahead and subtract increments of 360. So let's see, 1,215 minus 360, that gives us 855. which is still too large. So I'm going to keep subtracting increments of 360. That gives me 495, which is still too large. So I'm going to go ahead and subtract again. You're going to keep doing this until you get something in between 0 and 360. And this is 135 degrees, which is definitely somewhere in between 0 and 360, okay? So we're good. So our coterminal angle is 135 degrees. 1,215 degrees ends up in the same spot as 135 degrees, okay? 135 degrees is where? 135 degrees somewhere in quadrant 2. Okay, so you draw it out, make sure that you guys do, and then you're going to hug the x-axis. Now, I know a lot of you are going to try to skip this drawing part. I highly encourage you guys not to, okay? I'm all about efficiency, but when it comes to reference triangles later on, you're going to need to see it, okay? You need to be a very visual person in this aspect, okay? Hug the x-axis. Your reference angle is right there at theta. It's always inside the triangle and closest to the origin. You wouldn't put theta here because that's not inside the triangle there, okay? Okay, so we know we're in quadrant 2, so we can plug that in there. So the reference angle. How do we find the reference angle? I know that this here is a semicircle, so that's 180. So they're supplementary. So theta has to be 180 minus the 135. That'll give me the leftover, which is 45 degrees. And that's it. Let's try a couple more and then we'll be on our way. Okay, here's part C. Negative 559 degrees, okay? So from 0 to 360 here, negative 559 is somewhere over here. Definitely way too small. So whenever an angle is too small, we have to make it larger. So instead of subtracting 360, we're going to add increments of 360. So when it's too large, we subtract. When it's too small, we add. Okay? What you're trying to do is you're trying to push this so that it's somewhere in between 0 and 360. So here we go. Negative 559 plus 360 gives us negative 199 degrees, which is still not in between 0 and 360. So I'll go ahead and add another increment of 360. And that gives me positive 161 degrees, which is definitely somewhere in between 0 and 360. So the coterminal angle is 161 degrees, which lies in which quadrant? Okay, so if I'm thinking about this here, I know that this is 0, this is 90, this is 180, this is 270, and this is 360. Going counterclockwise, 161 degrees is definitely somewhere over here. That's 161 degrees. Okay, so we know we're in quadrant 2. Most important step, we hug our x-axis. So our theta here logically should be in reference to a semicircle. So 180, take away the 161 should give us theta there. And that comes out to, what is that, 19 degrees? And that's it. Is this my last one? I think, yeah, this is my last one here. The other one's a duplicate. Try this one. And then press play when you're ready. So here for the rotation of negative 341 degrees, this angle is definitely too small. So we're going to add increments of 360 for our coterminal angle here. If we add 360, we should get a positive, what is that, 19 degrees? Hopefully I'm doing my math right. 19 degrees. And is 19 somewhere in between 0 and 360? Absolutely. So our coterminal angle is 19 degrees. I know that 19 degrees is somewhere in quadrant 1. Okay, so if we're looking at the reference angle inside the triangle, that should be exactly the same as the angle that we have here. So in quadrant 1, it's pretty easy to figure out. The reference angle is 19 degrees, the same thing, but only when you're in quadrant 1. Okay? Big takeaways. Make sure you guys understand the difference between coterminal angle and a reference angle. Okay? A coterminal angle is pretty much like the reduced version of your angle. Okay? You end up in the same spot. So if they give you something that's not in the usual 0 through 360, you want to quote unquote reduce that angle until it's somewhere in between. Okay? Now, a reference angle is the acute angle inside the reference triangle that you make. Okay? Now, the only time a coterminal angle is equal to a reference angle is if you're in quadrant 1. Okay? Whenever the angle is in quadrants 2, 3, and 4, your reference angle should always be different from your coterminal angle. That's it. Go ahead and practice. Again, we're connecting 3 parts that we've learned so far: quadrants, reference angles, and coterminal angles. We're just putting it all together. Okay? Text me if you have any questions.